the video on and then by then.
5 seconds to go. Okay. Hello, I'm El Kaka. I'm a smart contract security researcher for 3 years. I've been working for different protocols, including smart contracts from AMMs, staking, bridge and acquisition protocols, uh, layer 2 protocols, and ZK knowledge, including smart wallets, account abstraction, etc. I've also worked in different ecosystems, including EVM, Solana, Stellar blockchain, and move-related language blockchains like Ops and Sui, as well as Starknet. I am an individual security researcher who provide security service either as solo auditor or with companies. You can check out my portfolio from the link down below. And Twitter profile is social media I use to post everything, any new work, and I also post some security tips and some issues, common issues, and talk about Web3 in general and Web3 security in detail for Twitter. Don't miss to see the news from my Twitter profile. Sorry.
Yeah, so thank you very much, Kaka, for that introduction. It's a pleasure to have you. And to everyone else, of course, welcome to our Common Smart Contract Vulnerability series. Today is actually very interesting because today we are looking at compliance-driven smart contract auditing. We have a very wonderful speaker in the house. Of course, he has a lot of experience, just like you've heard from him. And then today we are looking at like I said, compliance-driven smart contract auditing, looking at ways where we can breach traditional financial crime prevention with Web3 security, especially in 2026, because I think if we take a look back at some of the hacks that have happened in Web3 space in this 2026, um, you'll be surprised that it still happens in 2026. I mean, as recent as June, like this month, we've had, I think, some incidents. I don't know, but I think there's this incident with 1 inch fusion. I think there was a third party resolver attack like that. Also the stuff with Aztec recently also. So this is 2026, and we cannot over or underestimate the importance of security when it comes to Web3. And today, of course, Kaka is going to take us through what we need to know to be able to withstand and survive most of these attacks. So um, stay tuned for the ride. Ask your questions. Feel free to drop your questions. We're live across X, LinkedIn. We'll be taking a look at your questions, of course, for our speaker. And yes, do invite your friends, and then we get kick rolling right now. So, El Kaka, over to you. Thank you very much for having us.
You're welcome. You're welcome. Today, I'm going to talk about common smart contract vulnerabilities. There are a lot of vulnerabilities in smart contracts. Some is repetitive, like the same issue is repeated more and more, and some issues are like unique. Today, we are going to talk about the common vulnerabilities that are presented a lot in smart contracts. We will talk about 4 different things. First, we'll talk about top vulnerabilities in smart contracts and the common mistakes made by the developer side. In the second section, we will take a real-world example where a simple check and a common mistake that is sometimes forgotten by the developer lead to a critical loss of funds for one of the big protocols. In the third section, we'll talk about the prevention patterns and what developers can do to protect their code as they can from vulnerabilities, issues, getting hacked, etc. And the last section is we will go to code walkthrough where we will take some simple contracts that are vulnerable and we will point what is the issue in them. Okay. Let's start with top vulnerabilities. There are different types of vulnerabilities. Like we can categorize them into two different things: business logic vulnerabilities and the input error vulnerabilities. Business logic vulnerabilities, we will not talk about it today because it's like related to the protocol itself. Like each protocol has its code, has its features. Some protocols implement a unique feature for themselves. So if there is an issue in the protocol itself, or a given feature they introduced, or something that is unique to this protocol, so it's like a business logic vulnerability. It's a vulnerability that related to this protocol itself and not any other protocol. Input validation vulnerabilities or common vulnerabilities that we are talking about today are the vulnerabilities that its root cause is common and not related to the protocol type. So they can be found in different protocols and they are found a lot because most of the vulnerabilities are like most of the protocols are like have same features. Like if we're talking about staking, it have the same features, but some protocols like introduce one new feature, two new features, etc. So like common vulnerabilities and the issues can be repeated in between different protocols uh, more than a business vulnerabilities where it's unique to a protocol itself. Top vulnerabilities in smart contracts. We take the five, which I see are like the most vulnerabilities that are repeated, especially 2026, that lead to loss of funds and hacking of smart contracts. The first thing is access control. The second is price manipulation. Access control is simply a given function that should be called by restricted addresses like the protocol itself, something like this. Mostly it's like pausing contract, upgrading a contract, withdrawing all the funds if this a check was not made correctly and could be bypassed by an attacker. So it's like the attacker can go and impersonate the admins and can withdraw all the funds, emergency withdraw or emergency pause the contract and affect the protocol. Price manipulation is, as we know, it's like DeFi. Most of the protocols are depending on trading currencies, have drug exchanges, trading options, perpetuals, poly markets. So to get real time price of a given asset is important. So if this asset goes wrong or its price read wrong, so it's like a lot of issues can occur, like in trading process. If I'm going to swap Bitcoin and ETH, if the real price of Bitcoin was 80K and the Oracle or the smart contract read it as 20, so the final output will be totally incorrect. Lack of input validation. This is an abstract vulnerabilities that differ according to the protocol implementation, where in some situations where a given function is implemented in a given protocol, they miss a given important input validations. Like if we are going to see examples, like we should, for example, check for the amount. If you are going to add amount to not disaster overflow, you should make sure that the address is going to receive the funds can actually receive the funds and something like this. But this is like simple ones. In more and more complex protocols with more features, there should be a lot of input validations. And in most cases, and a lot, the issue is like a simple and only one check was lagged, which lead to an issue. Uh, Forcing is arithmetic errors. And this is related to the math itself. Like, for example, for these stochastic changes, they are depending on algorithms for determining the price of trading, the price of the asset, what the receiver will take, and what will be taken for the liquidity providers, how the fees is accumulated, as well as taken contracts where in the flow of tokens and funds. There are a lot of mathematical equations. So if there is an error in the mathematical equation, which can lead to overflow, underflow, or the revert. So this lead to issues. Proxy and upgradability, where like today, most of the smart contract I see introduce a upgradability proxy and upgradable proxy pattern, where instead of making the smart contract immutable, they are using proxy to allow them to upgrade the contract if they need. But if they didn't implement the upgrading process perfectly, it can lead to issues when they are going to upgrade, or they may result in upgrading with incorrect logic, leads to incorrect final output. Access control is the most critical vulnerability in smart contracts. Like in many protocols, and actually most of them have some privilege addresses and some critical functions that shouldn't be called by anyone, like pausing contracts, withdrawing of funds, uh, blacklisting a given user, etc. Most of these vulnerabilities are like not Web3 or smart contract related. It's like more Web2 related, where most of the times it's like the private key of the admin gets stolen from somehow, etc. We all remember in February 2025 where the attackers gained access to the private key of Bybit and would be able to lead their safe wallet sign a given malicious transaction, which lead to 1.4 billion of dollars gone. But in smart contract, you can actually do some things and safeguards that protect you from access control vulnerabilities, and we will talk about them in the third section. Price manipulation is also the main point of a lot of hacks, where in simple terms, the attacker is don't only want to let the protocol read an incorrect price, and if the protocol read incorrect price, it will lead to incorrect result. So it's simply like if is going to buy a Bitcoin from a given distressed exchange, he will simply, if the Bitcoin is worth $80 and he could deceive the protocol to let it re-sync or read the price of Bitcoin as like $1,000, he would take an 80 profit, where he will only pay 1,000 and take one Bitcoin. But in reality, one Bitcoin was 80K. So he actually stole $79 from the protocol. In January 2026, Machina Finance Machine share all code faced draining of funds because of not using TWAP, time weighted oracles. In simple terms, oracles are simply reading data from something outside the blockchain. But they was not using TWAP time weighted oracles, but they were using spot. Spot is simply reading the price as it is. It's like using this try to change like Uniswap or something like this. I'm reading the price at that block. TWAP is simply in a given range of blocks, let's say 20 blocks or something. So this is Ethereum like 3 minutes. Give me the average price of the given amount. So top is perfect because it gives you the average. But the problem with the spot is simply if you are going to read, given attacker can simply flash loan, like taking a massive amount of fund, loan them, and manipulate the price because it depends on supply and demand algorithm. So the price will be affected, either go significantly higher or significantly lower. And then if the oracles take the price of the asset at that point, it will lead to incorrect price because it is simply at that block only and not a real price of asset. That was the issue with that was lead to 4 million funds stand from the Machina because of not using TWAP oracles. Lack of email validation also, like some developers may like introduce new features after they finish the contract. They like may, oh, we need to add this feature. Let's say, what if we added this? And in that process, they may forget a given line to check, forget to add an important check that is required by their contract. And at this point, the attacker can take advantage of this mistake and let him take access from from things that is not his right, like store of funds, accessing private data, and upgradable contracts where it is like as we mentioned, referred to as properties now, where it allows them to add new features of the protocol easily without like deploying another one and the migration, etc. But if the developers are not aware of that, of what they are doing, they can break the protocol by themselves. For example, a storage collision, where when you are upgrading contract, you are adding new features, adding new variables. If you are not making sure that these new variables are not going to override a given storage loss from another variables, you should take this point where this will lead to like if you have like variable balances and you are going to add a new variable like white lists, if that goes to zero, so data will override each other. Another issue which was found in the previous year 2025 and was discussed in the dev connect DeFi Security Summit is CPIPM, which is proxy in the middle attack, where in simple terms, when you are upgrading your contract, an attacker front run you and upgrade the contract himself, but with fake implementation, and you don't know that this either by logs, either by Etherscan, all of this they are handling them. So when you think that oh the upgraded contract had happened correctly, but in reality the attacker took the protocol to himself. So you should take care of when you're upgrading. And in simple, and the best thing is to let the upgrading process by the authority address and not depend on the first one to upgrade is will be ours. And even if someone upgraded, we will simply ignore his version and use our version. No, it's best to double check after upgrading process, double checking the logs, double checking the real data so that everything goes correctly. Okay, now let's talk about a given real world example where a given protocol faced a massive loss of funds. We're going to talk about CETUS protocol. CETUS is a biggest decentralized change on Sui blockchain. In 2025, he suffered 223 million loss of fund because of a simple mistake, which is a flaw in shift left. In simple terms, they are going when the status is a digital exchange depending on concentrated liquidity. Concentrated liquidity is simply instead of distributing all liquidity at once, the liquidity is distributed between decks. So what happened is simply when the upgrading of the liquidity, the protocols are like rounding to 18 decimals or something like this, so that they acquire all token decimals. So in the calculations, they used scaling and they were scaling by 64. The problem is that in their check shifting left, the move language is like, which is language suite is like solidity. If the shift leads to overflow or underflow, it will not revert. So they used a given library to shift left their variable, but there was an issue in the shift left function where the check was incorrect, which lead to if the variable is actually going to overflow, it will be accepted. So that allows the attacker to submit a large amount, and the protocol calculates that what he needs is actually significantly lower than the real value because of shifting left. Here is the effective function. This was a function in a given library used by different protocols other than status, where the value is checked to be greater than the U.fix the maximum value, and if it is greater, so it's simply return zero, and if not, the value is lifted to 64. Shift left 64 is like multiplying by 2 power 64. Oh, yeah, 2 power 64. The problem was in this function, where actually the value can overflow even if it's not greater than the type u256 max, because if the value is like, let's say, u256 subtracting 10 or something like this, what if we multiply this value by 2, 3, 4, 5? It will exceed the u256 dot max, which is the maximum bytes that can this variable occupy, which will lead to truncation from the left shift. So the value will be returned incorrectly. So the attacker did the following. He first take a flash loan so that he can maximize the attack. He focused on a very narrow tick range, where in that very narrow tick range the liquidity becomes high value. So he need a value greater than uint 192, and we will explain why this value, so that he can truncation, so that it can truncate. Where you into 192, if you are going to shift left it by 64, you will reach the U256. So if the value is greater than this, you will lead to truncating the first byte. And the more bytes you add, more than you to 192, the more bytes you are going to truncate, the less value it will be. So he focused on very narrow tick range. He called add liquidity with a large amount, larger than U192 max, so that when calling check shift left, it leads to wrapping and truncation of some numbers, which will lead to adding the liquidity he needs to put in order to give that large amount simply smaller than the real value because of truncation. Because the incorrect overflow condition allow an unsafe intermediate, because this it leads to truncation of value. And after the value truncate, the calculations goes incorrectly. So instead of like we need from you $1 million, it's like we need from you $10 only, because of the truncation of the of a given numbers. And if the number, let's say 1,010,000, if you truncate the one, so the value will be ended like $10. And after that, so he managed to add a huge liquidity to himself by only depositing small amount. He calls remove liquidity and take all of the funds that gets deposited to himself, and then pays the flash loan he took, and keep the remaining funds for himself. After that, actually, Citizen Protocol has both the contract and connected with Sweep blockchain, and the attacker was managed to freeze like $70 million to Ethereum blockchain, and there was like 162 million remaining in the Sweep blockchain. So after they talked to Sweep blockchain has freezed the validator and prevented the moving of funds. So it's like they mitigated or somehow like they saved $162 million from 223, which is like not bad. It's like good. You saved more than half. And this was in the Mass Library itself, as we mentioned, which affected Morse protocol than Theta. So SWI protocol connects all of the protocols that use this library to upgrade their contracts and to not use this library after fixing it. It was a really huge issue in the world of security. Uh, and for the fixing of this issue, it's actually simple. Where, as we mentioned, if you added a variable more than 109 u into 192, it will lead to overflow. It is a snake where why is the issue occur? The check was made for 256 max, and the value is shift lifted by 64, which is like multiplying by 2 power 64. So the actual check should be 256 max sub dividing by 2 power 64, which is a really check in the beginning. You will go back to yes, that's really check the first F line. This check should be instead of type YouTube text should be type 192. This is a fix of the issue. And as we mentioned, like if the attacker has added, so to make a truncation, he need to add a value more than 2 power 192, which if the check was made correctly, it would be reverted. The third section we'll talk about today is the prevention patterns. Uh, you may like, okay, the security is for security people and development is like for developers. It's not like this. Like there are some things even you as a developer can take even before starting the development the process, the planning, or even as development process, you can add which will mitigate you from issues in the future issues that may occur or may not occur. It's like a design of the protocol itself. Like you as a developer, you can do the following. The first thing is like doing a lot of tests. Unit tests are important, important, important. Some people may see it like, okay, I know what this function do, so I will not make any test for it. It's like simple changing variable, or like it's like pause, or no, it's like every function should be tested, and every line of the code you should make a test for it so that you make sure that everything works as you expect. And if you introduce a given feature, when running your test, if it will lead to break a given function or another function, it will your test will show it to you. Uh, Also, fuzzing test and invariant test where instead of just testing by only one variable or something, fuzzing test where you test for different variables. Like for example, if you have a deposit function, you make a fuzzing test where you deposit zero, you deposit maximum, you 56, you deposit all of the available uh, parameters amount accepted, and invariant test where you test the overall protocol, which you keep invariant. Like for example, if you have a staking contract or like a given escrow, you should make sure that the given in the total internal balance in the imbalance variable equals the total the actual total tokens the protocol held. So you should make sure that even after a given interaction to the protocol, like depositing, withdrawing, pausing, composing, the total internal balance of the protocol we calculate should match the balance we have. Formal verification is also important and good if you can do it. Like it is simply like changing your functions to a mathematical pattern, and it's like the functions of the protocol is like converted into mathematical equation. And if the variable, like for example the escrow example we mentioned earlier, that uh, all internal balances stored in the contract should match the actual ERC20 token held by the contract. You can it convert it into mathematical equation, and if it breaks at a given point, he let you know about it. AI security tools, which is like the new trend now, can also help you. There are some and they're really good free tools like Bash of Skill, like Cypherin, like Bits, and there are also different languages like Bits have for Solidities, for Solana, and more. And also like the last thing is doing security review, which is the last step you take to make sure that the protocol works correctly. These are the points where developer can do. But it's like you do outside the smart contract itself. It's like doing tests or something like this. It's like outside the contract itself. The thing that the developer can do in the contract coding itself, where it can allow him to mitigate even common vulnerabilities that can introduce, like authority rules, where instead of just having only owner, which has the full authority power to pause and unpause, to withdraw, to whitelist users, unwhitelist user, etc., etc. No, you have different authority levels. So if a given key or if a given rule, one of its members gets compromised, you don't lose access to all of your protocol. You only get lost a given function or two functions. So it lists the issues and can allow you to mitigate it. Another point is the governance ownership of the contract, and this is really, really important. Where instead of having the ownership, the owner of the contract who can withdraw all of the funds at emergency situation, simply address EOE or even a multi-sig wallet, it's like a governance contract where before executing any operation, it like let it have a grace period where like 2 days, 3 days before executing the operation, and if the operation is malicious from a given attacker or something like this, so you notice it before its execution and they can take the important steps. Also, the rate limiter. Rate limiter is simply preventing the flow of funds all at once from your protocol. So let's say you have a protocol with $50 million and you make a rate limiter 1 million per day. If a given attack occurs that can lead to stall of all of funds, because of the rate limiter, the attacker will only be able to withdraw and stall only 1 million because of rate limiter, and he needs to wait for the next day to withdraw another 1 million because you are setting a rate limiter to only 1 million per day. So if you get the stall, you can take actions and to protect the remaining funds from stolen, which is really a good feature and design. And also, like the last thing is like if you are going to use libraries, use a well-known and audited libraries. Like OpenWrite in Solidity is the most and well-known library. It's really audited, it's battle tested, and it's really good, very good, and you can depend on it. Also, there are a Solid Day and Soulmate. There are some different vulnerable libraries, but OpenWrite is the most popular one. Here are some examples. Like here is the ownership. Let's say we have like three functions in the left: withdraw, set, trade, both. All of them are only accessible by the owner. So if the owner gets compromised or gets his wallet stolen, the attacker can set the rate, can post, can withdraw. On the other side, the good pattern is like the withdrawing is only for owners. The set rate is only for a given operator, which like those determine the staking rates for stakers. Post contract is for a given contract that can post a post contract. This is better for security, so that if a given address gets compromised, you don't lose access to all of the functions. Here's another example for the governance ownership, where if you have an emergency withdrawal, which is mostly a function that allows to withdraw all of the funds. If you are making it an only owner function, which is an EUA address or multi-sig, it can, if it gets stolen, or if the multi-sig gets compromised and you signed a given message that is not real, like the access of private, you will lose everything. But if you have a governance contract where before executing any operation, there should be like voting proposals, and even after the agreement of a given function to execute, there was like grace period, like 2 days, 3 days before executing the given function. So if an attack occurred in the governance contract, you would have time to take action before the attack occurred. Uh, there is another preparation pattern is the rate limiter, where as we can see in the left, we have withdraw function. It's simply checking that the contract balance uh, have enough balance to withdraw. But in the other on the other side, you will see that there is also a required check for the rate limiter, where if the amount is too large, the rate limiter will revert and will return false, so that it will not allow to withdraw all of the funds at once because it is also rate limiter. Last section is a code walkthrough, where we will, after we talked about common vulnerabilities and we take a real example and we talked about some good patterns and good features that developers can do, we're going to take some examples, some simple ones. We're not going too deep because of the time and because I want to make it like easier to review for all of the group of people. The first code like is simply casting issue. It's like casting issue. Casting issues is simply in Solidity, and I think in a lot of Solid languages, where if you are going to downcast from a large variable to smaller, like from you to 256, which takes 62 bytes, to you into 128, which takes 16 bytes, it's like you are going, instead of 32 bytes, you are going to smalling it to 16 bytes. So if there are numbers and data after the first 16 bytes, what they will go or what will happen to them? In reality, they will simply lost. They will get truncated, as a situation where we talked about shift lifting in the six protocol. So in some situations in big protocols, you can see that they are downcasting from large variable to smaller variable without proper check. So this lead to calculating the value totally incorrect. Like for example, in the example and the code we are mentioning there, if the amount input by the user was like u in 128 plus 10, after casting down casting it to 128, it will simply be 9 units. So at the end, the balance of the sender will get increased by like a very, very large number, and we will only require that the message value he put with the ether he send it to us is simply 9 units, 9 ways. The issue may be simple, and you may think like, oh, it's like I don't think that the developer can fill in such a situation. But it's just for an example, like to we there was a contest in Cantina, where contest is like a competition for security researchers for a different code base to find all of the issues in the given code base. It was for Eagle Layer. There was this issue was exist in it, but it was not that simple. And this is like because of it's a snipped, you may see like it's too obvious, but it was like not that obvious because of the code was large. But it has the same idea. Was downcasting it can lead to massive store of fund and massive loss of fund, and it was rated as high in the end of the competition. The second issue I'm talking about is related to staking contracts. Staking contracts are like one of the popular and most famous popular contracts in the smart contracts and DeFi. They are used a lot, and it is this issue we are talking about is not limited to staking. It is related to any contract which has rewards or interests distributed, etc. Where there's like rate. Which, for example, like each month we distribute 100 tokens, 1000 tokens, etc. This variable can be changed for the owner. Like let's say I set it to 1000 token per month. I change it to 2000, etc. The problem is that when you are changing the variable, like you should make sure that you distribute the rewards before that. So let's say if I'm going to distribute 100 tokens per month, and after the half of the month passed, and some users goes into the staking contract at this period, and goes into the staking process when the rate was 100, and I changed it. Let's say I changed it to only 50. So I should make sure before changing it to distribute the rewards the people who entered the staking before or entered my protocol before I change the rate so that they take their reward based on the previous value, and then I change the value instead of just changing the value, so that when a given user like try to claim his fund at the end of the month, instead of like taking from the 15 months 100 and the last 15 for the 15, first 15 days $100 and the last 15 days like $50, so total 150. He take 50 in the first 15 and 50 in the second 15, so it's like a 100. So he is actually losing. This is like a given issue in issue that common exists in stable contract, and most of the contracts are distributing funds where if they are making a changeable rate, they should make sure to update the reward before distributing. And like for example, the mitigation for this issue is like calling the internal function update reward index before changing the mint rate to the new mint rate, so that we increases the mint amount and increase the reward index, which is like the global rate for users, so that we know we increase the users rate according to how this rate is more than the how in this index is more than the index of the user itself, which is determined based on the moment he enters the staking contract. The last issue we are talking about today is like to the bridge protocol. Bridge protocols, like there are a lot of issues in the bridge protocols, and most of them are actually the same issue, which is the message forging. Message forging is simply the bridge. To give a brief definition of it, is simply you are depositing tokens in a given blockchain and you receive it in another blockchain. Let's say you are bridging Ether from Polygon to Ethereum, from Ethereum to Binance. You are bridging USDC, USDT, or any ERC20 from Binance's market chain to Polygon to Avalanche to Base, etc. So you should these protocols or this contract have two instances, like an instance in the source blockchain and an instance in the destination chain. If the protocol if the protocol can't know and can't mine the actual message and the actual data from the source and the destination, it can't verify it. So like everyone can mock one another person deposit and stole it. For example, in this issue we are talking, like it's less, yeah, like I don't think there may be a bridge protocol today have this common mistake. Like when we see the deposit function, we are having a hash constructing it for the sender and the value and the destination chain ID. The chain ID of the destination are going to send. The problem is that in the release we are making this that hash we made from the source, sender, amount, destination chain. We're making sure that the hash is not proceed, and if we then make it proceed so that the user don't replace receiving the funds from the destination chain. Then we are calling a verify function, which is mostly like calling to the signers or off-chain system made by the bridge protocol so that they are actually signed for that message. So it's like, okay, we received that message from the source chain, and we accept that this user we accept to send him that amount in the destination, and then we send the money to the user. There are a lot of issues in this. Like for example, we don't include the source chain ID in the hash. So like for example, you may make a deposit on Binance Smart Chain, and then you to a given like to a different destination chain. Let's say you make a deposit on Ethereum to Polygon, and then you uh, you mocked it from a given. It gets conflicted from another deposit for the same destination chain, same sender, same message value, but from another blockchain, like for another source. Let's say we have three blockchains: Polygon, Binance Smart Chain, and Base. In Base and Polygon, same users sending the same amount to the same destination chain, which is like Ethereum. So me as an off-chain system, like I accepted one hash. So only one of them will take his funds. So which is and the other will not take. Another issue is like we are not including the receiver of the funds. We are only including the sender. So if I'm going to send message to send like Ether or ERC20 to a given address on destination. Anyone can put any two address and store my funds. Bridge protocol actually the message itself is like the main thing that you should take care about. Constructing the hash should include every information like the sender, the receiver, the value, the source chain ID, the destination chain ID, and even another parameters. They are sometimes including the timestamp itself. They are sometimes including the block number, and they are sometimes like having a given launch for hashes so that they know the number. This like each method has a unique launch. The bridge codes are like a wide place for issues, and all of them, and most of them lie in the hash construction. Hash construction is one of the critical and important things of blockchain, where you should include everything, every data, any data in that hash, and make sure that the signing of it can't be uh, displayed in another blockchain or can be denied from a given source chain, etc. and that's it. I hope I could add something to us too. And if you have any question, feel free to ask.
Amazing, amazing. Thank you very much, Kaka. That was quite a walkthrough. Very interesting things that I learned personally. Some of the major vulnerabilities, like we stated, could arise from access control, arithmetic errors, impure validations, and of course the proxy of vulnerability we talked about, which is very important because I think recently also the Aztec, there was this, I think in June, there was this Aztec Connect exploit that actually had to do with a deprecated contract, and I think about 2 million was taken from there. But with everything you've said, it's quite clear why um, we should pay more attention to
Yeah.
deploying first an immutable system in a decentralized system. So security should be of top importance. So I'm just going to take a minute to check on our socials if we have any questions. Um, but I'll ask my question first and foremost. With everything you said, you also touched on prevention techniques, which is also very, very important, especially the aspect of testing. So testing can never be overemphasized because when it comes to a decentralized system like the blockchain, one simple mistake or yeah, one simple mistake could actually be very, very critical. It could cause damages that are beyond repairs. So it's very important to pay attention to all of that. So you also mentioned the case of the Cetus project or SU. I wanted to like maybe if you could shed more light on the actual vulnerability and like if you have like a figure of how much affect was in that hack.
Right. All right. Sorry, could you repeat the question? I didn't hear you very well.
Okay, I was talking about Cetus. You mentioned
Status, status
yeah.
protocol. We're talking about status protocol. Yeah.
Yeah. Okay. So I just wanted like maybe you could share like exactly um, like how much asset was lost and also what was actually like the core vulnerability that led to the asset loss.
The attacker actually, I don't know the attacker. I think like it's not known till today. Maybe some people say Lazarus Group, but this is not confirmed as of my knowledge. Like, and
Uh,
the amount stored was 223 million. Like, and the mitigated funds was 162. These funds, 162, there was like a proposal from the SWI validators. It will be distributed to the wallet occupied by SETA so that it can be distributed to the stakeholders and the liquidity providers for in this protocol. This was a process, but I didn't follow all of them up for it.
yeah. So thank you very much for sharing that. Over the years, some years back, if this happened, we'd be like, okay, but nowadays, with the advancement, of course, there's still much going on and much to be done. But with the advancement in innovation and, of course, artificial intelligence, I think um, smart contracts and, of course, any decentralized protocol um, because what I'm trying to say here is that if you take a look at some of the vulnerabilities that or incidents that have happened, it's not as if it's not as if this was invented. You know, those bugs were always there. It's just that with artificial intelligence now, you can find those bugs way faster, not just in the Web3 space, but generally also in the Web2 space. So, of course, this also opens opportunity to utilize the same artificial intelligence to ensure that, of course, we build and utilize better secured infrastructure. And I'm so happy you did mention the use of artificial intelligence security tools. So I believe this is also very, very essential. One common vulnerability, like the case of the humanity protocol, I think also this year, I think that was the case of the compromised private key, which I think people don't really think that their private keys can be compromised. But I'm just saying we shouldn't let our guards down on that. But in all and all, thank you very much, Kaka. It has been a very interesting session. We've had a lot of breakdown, which you have done, both in terms of the vulnerabilities and prevention. So
Yeah.
I'm going through the questions and I don't seem to see any questions for now. But yeah, so just share your final thoughts with us and then
Yes.
yeah, thank you.
Normal. I can see a question to like from like the same question like three times from Soran Tech. It's meant said if you could give one piece of advice to a new Web3 developer in Nigeria or Africa right now, what would it be? This is a good question to be honest. Today, it's not like 1 year or 2 years before. Uh, what what I would do is like simply studying Solidity, studying Foundry. I will not go for hard hat because like Foundry is more is easier to use, and most of the protocols are actually using it right now. So I will study Solidity, Foundry, and studying the protocols, protocol types like staking, AMMs, bridge protocols, smart contract, smart wallets, etc. Uh, the source of the source I recommend is Cyphering courses. They have a course for development. It's like a free platform, uh, and the courses I in the platform are made with good quality. They have a development course so that you can go for it. And after that, you learn about different protocols. Like I also know that Cypher have like course for Uniswap V2. It's important to know and Uniswap V3 and some other popular uh, protocols. So you should know the protocols after you learn, and after that you made some uh, projects and to increase your portfolio. And after that, you can go and apply for jobs. And in this overall process, you should make the AI in your hand. Like from the first step when you are learning, you should like depend on AI. Like it will ease your process of searching for given information. Like for if something you don't know, he can you can ask him and he gives you the source of information, etc. So like using AI today is like a must to my opinion. In my opinion, it is like a really, really good tool if you can use it. Like I don't like people who say I am afraid of AI. Like all I can do can AI do it. So like use it as a tool to increase your output and not make it like your enemy. Make it your friend. So that's it. So in brief to brief the answer, you will simply go to study Solidity and then Foundry and then the protocols, studying them, and the lastly you are going to make some projects, and after that you apply for Web3 developer role in different companies. and the platform I recommend is Siphon Updraft.
Yeah, amazing. Thank you very much. Of course, for all our listeners listening, we've heard it from El Kaka. So do well. Um, if you are a builder in the house, do well to do a security review of your project, especially your mainnet projects, even the ones that you're still having on staging. Do well to actually do some security review on that.
Okay. Bye.